All right, ECGR 4161 Introduction to Robotics. This is going to be lecture number 7. He does have his beard. We'll have to see that later. All right, so we have our presentations. Get it.
My name is Jessica Meeks. I'm doing the future of medical nanorobotics, which is pretty general, but basically the goals for nanorobotics in general going into the future are: 1, drug delivery, which basically means some sort of injection or possibly even a pill that goes in and can go straight to the source of your pain or whatever needs medication, especially like in cancer. For cancer patients, when they need to do chemotherapy, it can go straight to that and reduce the amount of chemicals that need to go into the body. Another is neural scans, which is a great advancement because you can actually see more in depth and do the synopsis and everything in the brain and see what's happening in real time if we can get the nanorobotics into the neural cortex and all that. And then for diagnosis, this is just basically imaging. You can do real-time imaging of like your heart pump and everything, but with diagnosis, more research needs to be done into biosensors, and so we can read heat and anything else that goes on in the body. Wish I was a biology major so I could tell you more about this, but there's also therapeutic, which is basically almost like a smart white blood cell. It would be completely autonomous. It would go through, and if a tumor appeared with sensors, then with sensors it would detect it and take the tumor and remove it. Or it would pump out and break up bacteria, like say you have a blood clot, like in this picture in the bottom right-hand corner for you. There would be clots around the edge, which is what's represented by the pink basic bubbles. And the nanorobots would go in and it would attack the clots and break it up so it would clear out the blood vessels. Another thing which I thought was interesting was dentistry. Like literally they're talking about your dentist going up, and instead of having your nice little cleaner lady who starts with you at the beginning of the visit, they would just like spray a spray in your mouth, and the little robots would go in and like clear all your plaque out. I thought it was really interesting. But the thing to implement all this is a lot of it's going to be done in swarms, because one nanorobot's not going to be much in all the little cells in your body, all the little makeups there are there. You're going to need more than one. So we're going to have to develop more swarm technology. And as far as injection into the system, if you're going to inject something into the body, it can't have like any oxygen or air bubbles in it. So you need some sort of liquid or some sort of basically filling. So when you do the injections, you're not pumping something that doesn't need to be in there besides the robots and some sort of safe liquid for the body. So beyond those limitations, there's also basic communications limitations going from outside the body, from deep within your brain. If you're having other synapses going on, it's going to be hard to communicate, as well as a safe test environment, because software isn't fully advanced to do the full body investigations and completely mirror what's happening. And that's basically it. Questions?
All right, next.
My name is Josh Morgan, and I did the AUR robotic desk lamp. And what this lamp was designed for was to demonstrate human-robot interaction with nonverbal behavior, such as movements with your hands, any kind of bodily movement to basically trigger the light to move where you want it to move. And it's aimed to evoke a personal relationship with the human by taking repeated actions and basically remembering what those mean, and then when it sees it again, it's going to re-implement that same movement so that the human using the lamp is able to kind of build a connection with the robot itself and feel like the robot understands the human and not just its motions. And it was originally thought up as a research project to study fluency in your behavior and how the humans are able to interact with the robots. And it tries to simulate the relationship between two humans as if they had worked together for a really long time and they've been doing the same skills for a long time by just taking the memorization of the movements that are repeated each and every time this action occurs and being able to replicate them over and over and over based on the human's movements and how it commands the actual lamp to move. And the robot actually learns through repetitive practice, and it also learns to anticipate movements from the human based on how it's moving, how it's about to move, where it's going, and other movements by the human. And I have a video of what it is like demonstrated by.
That's kind of old, 5 years old.
Yeah.
Nothing newer?
I mean, I didn't really find anything newer than this as far as like their technology. I think it's still in development, but I also saw another video that they had of him doing demonstrations where he had 3 stations, and each time he went to a different station, he would say a different color, and the light would change to a different color. And by the end of the demonstration, whenever he moved or started moving to a certain position, the lamp would already change to that color by the time it got to there. So it was almost like simultaneous. Whenever it arrived, whenever the human arrived, the lamp would arrive at that same color that he was telling it to change to. And this is just showing that the lamp basically understands the human's movements, and it's able to realize what the human wants it to do without any kind of verbal command. Based on previous verbal commands telling it what to do and kind of linking a movement behavior with an actual behavior. And that's basically it. And so it's able to follow, and then whenever he gets up and leaves, it knows to turn itself off. So. I thought this was pretty cool because not just desk lamps, it could also work with, it was actually modeled after a 5-degree freedom robotic arm that was able to do the same thing. It simulated a human's movement and followed their hand and their arm movements. And that's where they got the idea from, and to use it into like a desk lamp type of project. Are there any questions?
Can it differentiate between humans?
As far as the other testing, I'm not sure if it can, because in one of the videos, one of the actual, I think that was a concept video, but in one of the actual trial like research videos, he had this device on his hand, and I believe that's how the lamp knew where to go as far as in relationship to the person. So what it was set up. It was 3 stations. And he took his hand and he pointed at one station, or he walked over to the station and pointed at it and said green. And so the lamp would turn towards his hand, like towards the place, and turn green. And he would move to another station and say red. And by the end, he would just walk there, and then the lamp would automatically change to whatever color it was supposed to, because it remembered where, in respect to its start, that position was, where it needed to turn red and where it needed to turn green and blue. And it was actually set up like a triangle. So whenever he would walk from station 1 to station 3, skipping station 2, the lamp would go around starting at blue, and it would switch to red as soon as it hit station 2, and then by the time it got to station 3, it would have already switched back to green. So it's pretty cool, but I don't think it can differentiate between humans. Are there any other questions?
Hello, I'm Alex Monster. I'm going to talk to you about the robotic autonomous system that is the robotic leg and how it works, basically. Now, while the human leg is a rather rigid structure, there is some elastic materials that are required for the movements of the body, such as leg movements. You have to lift the leg up first, and it has two muscles that allow you to move up and down and swing it, basically. And there's some models that it's been compared to, such as the spring mass model, which can be seen right over on the right side. There are four major parts to a simple leg, which is the motor, some four muscles, which can often be used as simply springs, some passive joints, and some rubber to help it hold still when it stops somewhere, rather than just sliding around on the ground. Now, this knowledge can be taken and make a test robot system, such as the one in the top left here, that can sort of analyze and compare to a human's movement that can be analyzed. And then, using those two observations, you can kind of compare how a human leg moves as compared to a robotic leg built to work like it. While the method ignores some aspects of walking, such as turning on it while taking a step or such, you can basically get an idea of the dynamic behavior of the movements. That's all. Any questions?
My name is Barry Myers. I'm going to discuss the advancements in telesurgery. Telesurgery is a technique that allows surgeons to operate on a patient while being at a considerable distance away from the operating table. The first successful operation was done in France on a lady in 2001. The surgeon was based in New York City, so it's, thousands of miles away, operating on a very, small area. Pretty amazing stuff. So how does it work? Multiple robotics arms with very accurate and precise sensors are used to interact with the patient. Many cameras at different angles are used. Just to give the surgeon, a good view of what he's doing in there. And this is something we'll discuss a bit later. All the information is sent through the internet to the surgeon, who views it on a monitor and has a joystick almost that can, maneuver the cameras around his area that he's working in. And the robotic arms actually, have great precision, and they can be moved within, very slight distances. And today, the most commonly used robots for telesurgery is the Zeus and Da Vinci. The Da Vinci is a robot that's actually was designed in California, but it was first used in Greenville, North Carolina, at home at ECU at Brody School of Medicine. And the picture shows Dr. Chitwood, which was the first surgeon to have a robotic surgery. And that was in room, that wasn't telesurgery, but now he's recently started with the telesurgery program and has done surgeries in India, just here in North Carolina. So what is the future of telesurgery? So less delay transferring the data. Right now, I think the delay is about 200 milliseconds. So it's pretty good, but we want to even shorten that down and make it almost instantaneous if we can. More degrees of freedom in the robotic arms. Right now it's like 3 to 6, I think, that they're using. and a Devinci. So if we could get a little bit more, you know, they can control it and maneuver the arms better. Better monitoring systems such as 3D vision. They've talked about maybe surgeons having like goggles and like putting them on and being engulfed in a 3D environment, so the patient's right in front of them. And then more camera angles maybe, you know, being able to have more cameras displayed at the same time so the surgeons can look back and forth. And really the uses of telesurgery in the future, I mean, the main one that I read about was the battlefield. That's the main one, is being able to, you know, operate maybe in Iraq or something. Here in the USA, our surgeons can work on our troops. And then also the surgeon specification in rare operations. Just, you know, let's say we have this rare case and there's some guy in India who's studied this for years and years and years. He can perform surgery on someone here in Charlotte and get the job done. That's about it. Any questions? No? Thank you.
I'm going to be presenting automated self-guided vehicles. You may have seen these before or seen the television program including them. There's 3 types of automated self-guided vehicles: the deck truck, common forklift, and what's called a tow train. The deck truck, it carries heavy payloads. It's designed with 4 wheels or greater. You know, it improves its stability and the amount of payload it can carry. The forklift and the tow train generally has 3 wheels or more. The forklift, the single wheel on the back for 3 wheels allows the forklift to have a better turn radius. Some applications are container yards, assembly lines, and factories. The energy is battery operated. The CPU will notify when the battery is low and when the automated self-guided vehicle needs to go charge. It'll follow a path back that's already coded into the program that it's being sent to. But, you know, it's pre-programmed to follow a path in like the container yard or a factory. There are means of guidance systems, such as for fixed, it's a floor wire, a magnetic tape, or reflective tape that follows. And open guidance is laser, inertia. Semi-fixed is magnets. Magnets are embedded in the path that it follows. You can see that there is reflective tape here that this ASG is following. Some sensors. The only one I could really find was the encoder. The encoder tracks the vehicle position and velocity using odometry or dead reckoning. Some future advancements that are currently under study is complete autonomy, longer battery life, such as a better battery or solar powered. The deck truck can carry a larger payload, more efficiency, more advanced control algorithms. That's pretty much it. Any questions? Thanks.
Good afternoon, my name is Benjamin Rose. I'm going to be presenting on the Synergy MECs. This is actually a pretty exciting new technology that's come out. It first came out in 2007 for the research, but really hasn't been proven until this past year. Of course, with any new technology, you have to have a period of proving yourself, so the Synergy company has actually done this. It's actually made by infinite power solutions. And MEC is actually an acronym. It's micro energy cell. They've actually coined this phrase, hence the trademark in the presentation. So why we need this for embedded systems? Okay, so think about this. Most of the things that limit us is the batteries we have right now. We've used dry cell batteries for years and years, and 50, 70, most things are designed around dry cell batteries. We've had some, lithium-ion batteries in the past couple of years, but no long-term solution to the problem. This is a problem that Thenergy has addressed with their new MECs. What this is a thin-film, solid-state rechargeable battery. Now, what makes this different than most other rechargeable batteries is its type of the charge it can accept. It can also be done with constant current, with how most batteries are charged, like lithium-ion, for example. But the Thenergy can just be charged with any kind of current it takes, from microamp, nanoamp. It can be pulsed, it can be solid. This is very important for energy harvesting. So as you see here on the picture to your right is the alpha micro evaluation board. This has like solar cells on it to be able to harvest this energy. So what does this mean for embedded systems in robotics, for example, for this class, is that you can actually embed this in your system for the life of the system. So if you have a robot that needs to operate autonomously and just report back information, or a data logging sensor, for example, in a bridge or something, you can actually embed this in the concrete and never have to charge the battery again. Because just the sheer vibration from the cars going on the bridge will actually recharge the thin cell battery. So what does this mean for future technology? As we can see from our picture, just in the past 30 years, even as Dr. Conrad can attest to, that as technology grows, things get smaller and get better. So as you can see, hopefully none of you have the first cell phone that's ever been invented. Hopefully we have a little bit more towards the right end of the spectrum, but that's one of the major things that are limiting us in our technology right now. I mean, the other components need to be invented as well, but the battery technology is where the limiting factors are right now. So I think this Thenergy micro energy cell is really the answer to some of our embedded problems for the future. So, and again, it would be great to have a world with no chargers. That would be awesome. I know it would be for me. I hate charging my phone every day. Is there any questions?
How does it charge based on the vibrations of a car driving across the bridge?
It uses like vibration from the actual car. What it does actually is takes a kind of a piezoelectric, basically that same kind of thought. And what makes it unique is this LiPon material they use for electrolyte. That actually is what's being able to accept. That LiPon has actually only been out, like from what I can see, for about 3 or 4 years. So actually new technology. So they have to have like an energy harvesting device for that. So that's kind of built in-house. So they want much information about that. But they do have just like magnetic solar energy, so it's pretty awesome. Any other questions?
A lot of vibration harvesting is also due to a magnet and electrical field that is generated when the magnet moves. You can imagine it's not very much.
Any other questions? Thank you.
Salazar, and I'm going to talk about neurosurgery for the future. So right now we have the robotic systems that we have are used for assist the surgeons and extend or enhance their abilities or skills. For instance, the surgeon's average hand movement, like the treble, is about 40 micrometers. By using robotic systems, they can drop that down to like 4 micrometers. So it doesn't shake that much. Right now we have 3 systems that they are using currently. One is the supervisory control robotic system, which is when the surgeon program the robot using some kind of virtual environment, and then the robot operates while the surgeon is just supervise the movement. So if anything goes wrong or he needs to adjust something, he can stop the surgery and do the adjustments. The other one is the telesurgical, which is the one that he talked about, which is the one that uses joysticks and a monitor or some kind of scopes, and you can operate in real time in different places. And the other one is a shared control robotic system, which is when the surgeon uses some kind of robotic hands. So he's operating on time, but he's pretty much doing the operation with the assistance with the robot. So the future for robotics is they believe that in the future these robots are going to have artificial intelligence, AI, so they're going to be able to think and make decisions, things like that. So if a surgeon teaches the robot how to make certain surgery, the robot will perform the surgery, and then the more he does the surgery, the more he learns from himself and becomes better and better. They're also going to be able to program themselves. That's like rethinking, I guess, readjusting their own procedures. They're going to be more independent and more self-reliant. Challenges, human beings, they fear these technologies because nobody want to be operated by some kind of metal device that you don't know if it's going to make a mistake or something without supervision. Because the future of this is like having a robot that can perform some surgery without nobody being there, no supervision. So patients are a big concern that kind of doesn't let this technology to evolve at a rapid rate. And that's what I got. Any questions?
I have questions. Say if you are operating in the supervisory mode, right?
All right.
And which means that the doctor is there checking if the robot actually doing the job, right?
Yeah, he supervises but he first programmed the robot in some kind of virtual environment. So he does the surgery, he programmed the robot, and then he press OK, and then the robot starts doing it. But he's there supervising.
If the tolerance for is very, very small, so how can the doctor stop the
procedure?
Yeah,
like,
in case that.
Well, it's just, I would assume it's just pressing some kind of, I mean, he has control over a computer or something, so, the clock is very quick, so you can't stop it. I mean, we have what? Right now it's like dual core, quad cores, they're pretty fast, so yeah, I think you can't stop it. It would be able to stop it. Any other questions? All right.
This is the shape deposition manufacturing grasping hand, and shape deposition manufacturing is just similar to 3D printing, where a layer of material is put down. Any components such as sensors or cableways that you would want to put inside of the gripper, you install those. Another layer of material down, and you would have your finger. And with this type of manufacturing, each finger is a single piece and weighs considerably less than if it was machined from, say, aluminum or plastic or other types of materials. It requires fewer parts. This particular gripper uses only one actuator, which you can see at the bottom right here, and each finger has a stainless steel cable that runs past the first joint and up to the second joint, and when tension is pulled, it causes the finger to close. And this is a much simpler design than if you had, say, a stepper motor or servo motor inside each joint of the finger to cause it to move. And there's also a force sensor that is at the tips of the fingers that measures how far the rotors have pressed in to detect how much is gripping. And here's a And with this also, position doesn't have to be very accurate. You just have to get close enough to the object, and the gripper is designed to expand open or to go around the object. Whereas with other styles of grippers, the gripper is usually designed to perform around the object itself. So if you had different shapes, you would have to change grippers.
kind of like the claw that you play in.
Yeah. And with this type of manufacturing also, it allows, since you're not getting precisely over the object, the grippers are designed to flex possibly 2 inches in either direction. And is there any questions?
So if there was multiple CDs right there, would it be able to grab just one? Even I had trouble doing that.
Or it might not be able to grab more than one.
To answer your question, no, it's not like the game, because in the game, it doesn't actually grab anything.
Yeah. I don't know, I'm pretty good at it. I always want those little stuffed teddy bears.
They're set up to grab every like 20th or 25th, whatever it's set up in the actual claw.
People should chant and do all the time.
And I mean, it's like set to not apply enough force to pick anything up until like every 25th, so that the person still makes money.
Okay, so I'm Trip Taylor, and I'm doing an AR drone or a quadricopter as a platform for robotic research and education. The purpose for this robot and the reason the guys worked on it was to provide a basis for future educational use and pretty much to do the same thing we do with like the Danny Block, so that it can be used for educational purposes. It operates with an online processor and 128 megabytes of RAM, and then it has its own built-on Wi-Fi, so that you can connect it to just about any computer or flat wireless devices. It has a lot of different measurement units to figure out the tilt and the yaw and the pitch and everything like that. This is all shown here. It's got a front-facing camera that's higher quality than its downward-facing camera, which actually hurts it because on board it has to compress that file and send it, and so you actually get a slightly delayed picture. But these guys figured out a little hack that isn't paper. It's a little complex to cut down the amount of data transfers so it would be faster. But they used an open loop control setup for some of the required outputs of the bot, and then they also used a closed loop setup for some of it as well. Now these are the control blocks for how it tilts and whatnot to hover in position autonomously. You can see right here they have a moving bot right here, and they do it again later in this picture. And the downward facing camera, they use their own image processing that they did not share in the paper to determine where the target was below it. And they could actually drive around this little car right here, and as long as they kept the altitude of the quadricopter above 0.4 meters, because then the lower facing camera would start to like see a smaller image and it wouldn't work as well. So as long as they kept it above 0.4 meters, they could drive the car around and it would manage to stay hovering above the vehicle. And this all goes towards learning the same things we're learning in this class, only it's going to be more complicated. I mean, the future is going to have the next generations after their robotics are going to be something we probably couldn't even come up with today. And they'll be using platforms like this and the Danny-Bot to learn it. And here's my credits for you guys who wrote the paper. Any questions?
You cheated. That's more than one slide.
Right.
Yeah.
Well, the course was changed.
Minus 10.
It's actually a slide. It took me forever to figure out how to do that.
What was the open loop? How did they do the open loop? What did they do with the open loop control sequencing?
The open loop, they control the pitch, roll, yaw, rate,
Pitch,
and
roll.
the vertical speed. And that's why I threw this image up there so you guys can see which each piece was. But that pretty much, this bot already exists. You can go out and buy it, but these guys provide some directions to people who would like to use it in an educational setting without spending the initial 2 years that this team worked on it to work out the best way to operate it. The bot itself has a built-in system to work with I think it's the pitch, roll, and yaw and all that, and keep the motor speed and angles at a set rate. So that's why they were able to do these two closed loop setups to control it. And then they left onboard processing for maintaining those speeds.
How many cameras did you say that thing had?
2, front-facing one and a rear-facing camera. And this picture is taken with the rear, or I mean not rear, below. The camera underneath it.
I believe that's nothing more than the Parrot quad rotor.
It isn't. That's what it is.
And it's, which is out of the box controllable with an iPad or an iPhone.
Yeah, these guys have been working on it to make it autonomous. And I mean it's cool, but it's also scary to think about. These could be flying around above us, police, quadrocopters, monitor you. Any other questions?
Alright, I did my presentation on robotic mining in space. As with a lot of things, the next frontier is usually going into space and trying to work with something like that. Robotic mining units already exist. They're mining in South Africa, all sorts of different places, but what they're trying to aim for is asteroid mining or moon mining. And the actual mining robots aren't completely fitted for this type of venture yet. So there are a few factors that they need to cover. One being localization without GPS, because one thing is GPS doesn't work underground. And the other thing is there are no satellites around the moon that can provide GPS coverage. Another thing is that it needs to be small in size and weight. It needs to be able to go down inside an asteroid or the moon and fit into all sorts of little nooks and crannies to get the goodies. And also for transport, you don't want to be sending things into orbit that weigh a lot because it wastes a lot of fuel. Another big concern is the autonomous aspect of it. The robots are most likely going to be used in conjunction with one another, meaning they're going to be in a swarm. So they need to be able to communicate with each other in order to be more efficient. Another thing is you can't control these robots from Earth because there's such a long delay from the Earth to the moon or even a more further off asteroid. And since there are no people on the moon to control them yet, that's kind of out of the question. Another thing is the transport and storage of all the ores and metals that they collect. There are 3 options. They could send it back to Earth, which would require a lot more fuel. They could dock them in the International Space Station. I don't know how that would work out. Or they could just leave it on the moon in storage facilities. Another big factor about space mining is the profit you can make from it. Right now, economic projections suggest that there's not a lot of profit in currently starting it because the technology that exists right now doesn't allow for extended periods of space travel and permanent mining operations on different places. But the risk might be a lot less than the actual profit that you can make because a lot of these asteroids have maybe billions of dollars worth of materials on them. So That's why it'll be so important in the future. There's a little picture of what it might look like. Any questions?
How do they actually mine the ore?
It's a little robot that looks a lot like the Talon robot, if you remember. It's got tank treads and a drill. It's got a scanner unit. It's really similar, but it needs to be able to rugged terrain and fit into small places and be able to drill down deep. So it's really simple.
Do they blow it up afterwards? Do you think they changed like a trajectory from like landing them or something like that?
Anything else?
I'm John, and I'm going to talk about NAMO, and it stands for Navigation Among Movable Objects. And pretty much, it's just completing a task with reasoning. It's walking through a room without running into stuff, without stopping it, and turning around. It's actually getting through the room while actually being able not to be trapped in by movable objects. It just, as you can see from the screen, it is trapped in a corner. It maps out the room using the optical tracking and also the force sensors, and then plans its route on how to actually get out of the room. And it can also tell whether or not the objects are movable, or if they're bolted, or if they're stuck, or stuff like that. So it's got a lot of logarithms in them to be able to tell. And then also it's got joint encoders, which helps the robot to be able to track through the room. And then the future for this is just being able to actually get through the room without moving objects, and pretty much just, I'm sure you all have seen it like parkour kind of thing. But it's like a robot that just pretty much just runs and jumps off the walls and gets through the room without touching anything. And it's not going well, because the robots that they're building right now that can jump and do that are powerful. So when they jump off the wall again, they go through walls and stuff like that, and then they don't have enough symmetry to get to roll once they hit ground, so they'll just hit ground and then roll. And you're supposed to roll before you hit the ground, so they have a lot more that needs to go into it. But it should be really cool. I don't know. I think it'll be cool whenever they get through with it. But any questions?
So is it like human shaped?
Yeah. It's like human, and it just can get through a room just like you or I can.
How does it stick to the wall?
This one does. I'm not talking. This one doesn't stick to the wall. The future for this is running and it's like parkour. You've seen it before.
So if it moves something, does it move back when it gets around it?
It can.
Or does it just move and keep going?
It'll go up to a table and actually move it. It won't just throw it over.
Throw through the wall.
Yeah, just chuck the table across the room. No, it actually moves it. And whether or not it's told to move it back is whatever they decide. But it can move. It can put the room exactly back how it was after they get through it, or they can leave it just them walking through. But no, it doesn't throw stuff around while it walks through.
How does it determine where everything is in the room?
With the sensors that it has, it just the ultrasonic sensors and all that stuff just maps the entire room.
Okay.
Any questions?
All right. Let us take a 7-minute break. Go.
Alright, so this is on the future of robotics in the oil and gas industry. That's just the area, but the actual issue is bigger than that for the safety of humans. So that's where we have the problem here is the safety of humans in the industry of oil and gas, because there's a lot of toxic things that go on in those environments, and so that's why it's a prime spot for this future in robotics. The main thing with robotics in this industry is that they're static and that they lack a human and robot synergy, so you can't really have any communication things. They mainly have a specific task. That's what they do. Some of the key issues with going from a static environment to a more dynamic environment is trust. That's one of the big key issues, especially in the oil and gas industry, is can we trust this robot to do a job that a human is intended to do? And how good of a job and how specific can the different things be, like measuring the welds and things like that, making sure they're big enough and thick enough and that they're not cracking. Another thing is accountability. Is it going to be the same every time with different issues that come up? Another key issue is tools. Is it a tool or is it a workmate? So is this basically a fellow employee that's a robot, or is it a tool that you can use in the workplace? So with this, the interaction design, you want it to be more human-like or less human-like. So like this robot doesn't look very human, it's obviously doing just a task. So the autonomy of it, is it completely autonomous or semi-autonomous, depending on whether it's a tool. If it's a workmate, then it's going to be completely autonomous and just doing its job, or it could be a tool, so it's semi-autonomous. The complexity of the environment, the task, and the situational awareness. These main topics are the fact that in this oil and gas industry, things change and you kind of get to know your environment, you get to know the factory, and you kind of know what's normal and what's not normal. And so a robot might not be able to detect that there's a crack and a leaking gas, because that's not what they're supposed to be looking for. They're supposed to be looking for glue stuck somewhere and there's a crack. So someone who's a human being would notice that and think that's an error, we need to fix that. But a robot that's just has a task won't have that situational awareness for that. The solutions for this is the actual future of the robotics. This is the tele-inspection or tele-operations. So this is kind of a meshing of the autonomy of the robot, so that you can have both it doing its job, but also have an operator making sure that the other parts of the environment are there, or to even have complete autonomy, being able to create these robots so that they can inspect everything and also have that same situational awareness to notice that something is not normal, it's not the same as it has been the last 100 times I've done this sweep through this pipe. So this is just an example of a robot that does pipe inspection, and that's the end of it. Any questions?
Right. I chose to do an extremely broad topic, which is robotics in the military application. And from the previous ones today, you can see how many different things can be used in the military application. The Nemo stuff, for example, being able to traverse obstacles and get through buildings can be very helpful if we're going to try to create like a fully autonomous robot that would replace humans in warfare, which I think is eventually where we're headed, which would be pretty cool because we wouldn't have to send human lives overseas to risk their lives to fight for our freedom. Some of the things that the military is using right now in robotics is reconnaissance stuff. Anybody that's played any of the Call of Duty or games or anything will know that this down here is a UAV, which is like an unmanned aircraft that can fly over a section of area and map out different things and where people are and this, that, and the other. And then last week we had another presentation in that the guy was talking about the Talon, which is a weapon-based platform on tracks, and it can drive around or do different security things like that. So another big thing that they're using robotics for right now is ID investigation and elimination, which saves a lot of U.S. and various and sundry other human lives, which is always a good thing. And so I have a video of a DARPA project that but this is what DARPA's funding, one of the things they're funding right now, which is a project that will fully, eventually going to look like a human if I can get back to it.
You have to exit.
I had it set up on mine where it would
you have to click Control and then click on the link.
Maybe if I can get it.
Copy and paste.
There you go. Here. Alright, so this is just talking about projects. So here's what it looks like right now, sort of concept stuff. Has to kind of arm these things. They can walk up steps.
Hey, it's a chicken walker from Star Wars.
And it is more human-like again. And then there's a guy that comes in and pushes it. Oh, shoot, this is it. This guy pushes it and it balances itself out again. So, and here it kind of just looks around and scans the area for different objects. You can see 2 legs and 2 arms, so very human-like. Basically doing sweet push-ups, so hopefully this will be the future of military robotics, and we won't have to use any more human lives to do our bidding.
It's like the Terminator.
Does it get stronger when it does more push-ups?
I don't think so.
Maybe.
Any other questions?
You guys ready? Alright, so I'm going to talk about this snow eater robot. Alright, so this is a snow eater robot was developed in Japan, and the initial design was aiming to clean up the snow that was on the road and everything. But this is in Japan, and the houses, the road between houses and houses is like tighter, more like claustrophobic. So those like heavy duty like snow plowing machine doesn't go through, right? So this institute in Japan designed this the robot right here, and to clean up the snow and everything. And I mean, this robot kind of remind me. I don't know if you guys watched the Disney movie WALL-E. They actually compressed the snow into ice like cube and stacked up in the back like that. And for this robot, I couldn't find any video, but there's only pictures. And alright, so this robot is capable of taking the snow from the tray right here, actually right there, and here's the snow dragging mechanism, and here has 3 screws right here, and snow goes in right here, and it's moving this way. And here's an iron plate to prevent the snow stray going in from jamming the machine. So, and then it keeps flowing down, and it compresses it and send it back to this red tray right there to stack up. And the sensors for this robot has a GPS positioning sensor and twin video camera to avoid obstacles and detect snow and integral snow block maker and compressor. And this robot is aiming for $8,000 to $9,000, and will probably within the next 5 to 6 years, perhaps. And I just want to post this picture right there, like it modified to a Pikachu. Yeah. So, really cool. Yeah. So that's it.
Is this available in Walmart yet?
I I don't think Walmart sells something like $8,000 to $9,000 though. Huh?
Okay.
That's probably the question. Yeah.
Okay.
Yeah, go ahead.
How high does it stack up the cubes, or what is it?
I mean, how high does this? You talking about? Oh, the block?
Yeah.
I don't have the detail. I couldn't search for a detail for the how high it could stack up to, but you're probably gonna build a skyscraper.
Arnold with his notes.
Is that you? Who's women anymore?
I didn't know they had snow in Japan.
I mean, it's in North Japan that has a snow issue.
I'm sure mountains have snow. In fact, they once had a Winter Olympics there, so I'm really sure they had snow.
That was snow that was created, not
Really?
not snow that came down.
Okay, I'm Scott Collins, and I chose a different didn't necessarily choose one robot in particular, but chose a sector of robots which are supposed to really gain traction over the next 10 to 15 years. Supposedly there are 3 sectors. There's what is an industrial service robot. Definition for that is immobile, single task robot with little interaction with humans. Basically what's employed in all manufacturing. There's also a professional service robot, which can be anything like industrial cleaning equipment, maintenance, data acquisition, rehabilitation robots, and things of that nature. Then there's the personal service robots, which is defined by Robotics Trends as robots or robotic technology purchased by individual buyers or consumers, which educate, entertain, or assist in the home. And some of the different areas that they can be used in are entertainment, education, home security, medical care, housework routine, etc. The housework routine category has been done somewhat with the vacuum cleaners. There's lawn mowers out. A lot of this is over across seas and hasn't made it to this area yet. But I do believe John Deere actually has a lawn mower that does pretty well across seas. I don't know if it's expensive, but there's 2 different versions of actually those kind of lawn mowers, which are robotic. Personal service robots will be realized and fully boomed in the next 10 to 20 years, according to this research paper. Right now, there's a big push in the academia and research institutes of global enterprises such as Sony, NEC, and Philips. Some of the major items that have come out of there was in 1986, Honda began a robot research program. The main axis of development for the robot was it should coexist and cooperate with human beings. And then some other ones. Furby was the first robotic pest released in the commercial segment in 1998, followed by Sony with the ABO robotic pet. Was that the dog, I believe, that you had here?
No, that was an iCybe. I think that's actually Tiger Electronics.
Oh, okay, all right.
Or Silverlit, sorry, Silverlit.
Okay, and then Honda has got the first humanoid robot, I think, that's been produced, I believe, and it was produced in the year 2000. Robots, the whole idea is they should and they will understand human instructions or desire through use of sensor technology, motion technology, and intelligent technology. Technologies currently under development include spatial temporal cognition, which is object learning and recognition, scene and situation interpretation and understanding. There's motion technology. I'm sorry, there's decision making. Decision making is basically what would we do if we were in that position? What kind of decisions could it make for planning and reasoning? There's learning, keeping track of what it did in the past, learning from its mistakes or reprogram. Then there's interaction and communication. It needs to be able to talk with humans and participate with them. And according to a Japan Robotics Association study, the personal and professional service robots will triple that industry from 17.1 billion in 2010 to 51.7 billion in 2025. And some subtopics or fields of the technologies include system security, personal assistance, information, interfacing, identification, household, healthcare, entertainment, education, and communication. That's it. Any questions?
Can you teach you how to like wash dishes and stuff like that?
Somebody did.
It's called a dishwasher.
Like take the wife to the curb, man.
Hook your battery up to the pipe.
I chose the tactile gloves and autonomous grasping for the NASA robot. The glove in this robot has is rough and designed to protect the sensors, the tactile sensors and the pressure sensors from the wide range of planetary and space tasks that it will be doing. Both hands have incorporated an outer glove and a sensor layer. The outer glove is composed of two fabrics or two materials, meaning it's a hybrid of a fabric that doesn't let you sleep, doesn't let it sleep, and also a lycra blend fabric. The non-sleeping, it's made for surfaces when it's crucial for it not to sleep, like round shapes and not robust, so it could hold on to the objects. And the lycra, it's used for the parts to help shape the glove and create tension when needed to. The technology in its hands, it's considered state-of-the-art. It should be capable of allowing the robot to carry tasks such as changing air filters, manipulating objects, using tools. The future of this technology has been contemplating into sending the robot outside of the station, so he will provide help and assistance to the astronauts to help fix or make repairs. Also, the future on the tactile technology of the gloves. They're trying to improve the sensing area, since it's pretty much covered, the hand and the palm is pretty much covered with sensors, but there's still dead spaces or parts in the hand. So they're trying to relocate the sensor pads to areas where it covered the most, or adding more and slimmer packages. And they're also trying to reduce the wire count on the sensors, but this will allow to increase the resolution, since they are also going to be able to move the signal processing into the hands itself and not the forearm where they are located. Any questions?
Yeah, my question, man, what are you eating that's making your beard grow so fast?
Hello, my name is Neuro. Today I am presenting the teacher robot. If you remember, or if you go into the UCC career site, every now and then there's a whole bunch of illustration position in Korea, I guess. I don't know if you have seen those or not, but these robots are the prototypes built in Korea to replace those English teaching job. So I guess they want to send the American teacher home, I guess. If you think of a teacher robot, so the three main functions of the teacher robot should be to play multiple roles. So as a teacher, you want to teach a robot not only to deliver instructions, but also resolve conflicts and resolve complex problems happen during the classroom. The robot should also have the comprehensive skill set, such as the robot should know multiple subjects. So if a student happen to ask something along the line of the subject, but not directly in the subject the robot teaches, the robot should be able to answer it correctly. And the robot should also have the intelligence for logical behaviors and emotional interactions. So these functions can include assigning practice problems and also adjust the teaching styles and selecting the teaching contents based on the difficulty of the content. And also analyze a question asked by student and provide rationales to go to the results. The feature of the robots should be autonomous. The robot should have the ability to recognize the circumstances and interact freely with students. The robot should be independent, spontaneous, and interactive. And I think the most important feature is the ability to make decisions and has free will. However, there are limiting factors for the teacher robot. The main one and the biggest one, I think, is the interactive technologies. With the technology we have right now, I don't think the teacher robot have the ability to replace the human teachers. Because, for example, in the classroom, the robot cannot detect the atmosphere of the classroom. I think also one of the main function of the teacher, besides instructing, is the ability to engage the students and have the interactions with the students. And I don't think we're at that level where the teacher robot can perform those functions yet. Also, the next big thing is knowledge database. In order for the robot to be able to answer the question from the student, you have to build up the database and have teaching experience built into it so that it can be more dynamic, I guess. That's what I can put it. And that's all I have.
How well does it do with understanding accents?
That's a good question. I don't know that yet.
Did they tell you like the exact purpose of it? Like, is it to replace the teacher completely, or is it for like so students not to sit in front of a computer?
From the article I was reading, that's what it was built for. To replace the teacher completely.
So there's like a fight in the room with space now.
Get robot. It would just throw stuff.
It's going to paste them, right?
Yeah.
Now, this is where it's going to get tricky. Go to the next one. It may actually start talking when you go to that. Okay? No, it's not. So go to the next one after that.
What is this?
All right.
You skipping going?
Because he's not here. And I've got something else that plays it. Whose is this?
That's mine.
Go for it. It's your
Yeah, I
turn.
didn't have any sound on it when I was up there playing my video.
Sounds
So.
muted right now.
Oh, the volume. Yeah, the volume was on.
Yeah.
What is this?
Oh, human stuff.
Alright. My name is Herbert Hill, and I'm going to do a presentation on the powered exoskeleton by Exo. The company was originally named Berkeley Bionics, and then they changed the name. The purpose of this robotic technology is to help people that are paraplegic, which is being paralyzed from the waist down. In this model, this is one of the early ones. Yeah, one of the earlier ones. It weighs only 20 kilograms. The reason why they made it so lightweight was they had already started this technology in the military, And when they thought about it for rehabilitation purposes, they felt like there wasn't a need for a lot of weight since the person is just carrying the weight without a payload. Right now it's currently remote controlled by another user. The person wearing the suit's not able to move completely on their own. And it does have a battery pack, which is on the back just like a regular backpack that you would wear. And it has regular heel-to-toe walking gait, which is like if you're doing the military march type thing. The future plans for it is for it to be passed by the U.S. Food and Drug Administration. I think it already has because they've already put it in use at some rehabilitation centers. And they also want to put sensors under the walking sticks. If I have enough time, I'll show you a video where it's basically crutches, and under the crutch they want to put a sensor so that the legs know what to do when the crutch moves. They want to make it smaller, more lightweight, and they want it to be used for stroke patients as well. They wanted to have a better master of balance and for it to be in use in daily living, not at just the centers, but someone can take it home. So if I can get this video to show up, it'll give a video of how this works. So the crutches are what they use to hold themselves up, but the person behind is controlling the person that's actually walking.
Can you check the sound on the podium? Sound on the podium. Yeah.
Is she actually, is this person paralyzed?
Yes.
Check the sound on the computer.
That's all right.
Thumbs up.
Oh, it's somebody muted it on the computer.
Paralyzed for the next 20 years. How do you let the person sense it in the device?
So you actually see the person can't use it.
Perfectly in alignment and naturally. So the way we are doing that is actually through non-invasive force sensors that are embedded in the crutches. So when the person moves the crutch forward, it actually sends signal to a computer that is sitting on the back, surrounded by batteries that further drive four motors that are sitting both the hip and the knees. And so the opposite leg will move, and you move, for instance, the right crutch forward.
The basis for the technology was originally developed at the University of California, Berkeley, as a robotic suit that could enable soldiers to lift heavy loads. Since then, a new version has been developed for use by paraplegics, something which required applying very different principles.
As we managed to put the frame that
Yeah, so if you want, you can go to the site, but that's the whole idea of that part.
How do they keep the body up? How does the body stay up? Just from the torso strap?
Yeah, I think
the torso strap's that tight to be able to hold up the entire body?
Well, I think that's just the there's
It's
four.
straps all over. It goes all across the legs.
Yeah, it has 4 servos, which I'm thinking are in the. There are 2, one for each knee and in the hip, and the servo basically keeps you standing up straight. And they have the crutches to help you because it can't balance completely by itself. So that's why they have the crutches, and they want to improve that. So you're not doing that, but this is basically the same thing as walking down a rail in a rehabilitation center when you're trying to learn how to walk again.
Why don't they design it to where the remote goes into the crutches? So it could be user controlled instead of like
somebody following it?
Yeah, I'm not really sure. That was like when they first did it. They don't have a video of anything more recent. I think that was done last year, and they were trying to start implementing them in rehabilitation centers this year. So they might have changed that, but I'm not completely sure why.
So that people don't try to.
And again, this is not for military. This is for other types of patients, or patients. All right, next. We're running short on time, so we'll just go off to the next one.
I'll keep it short.
Thanks.
I'm Keith Hunter. What I want to talk about today is telepresence. That's not as much a future robotic technology as just a future technology that we can get through robots. And telepresence would be defined as being able to appear at, like you were there in person at, say, a meeting or with your kids at home somewhere if you were on business away, and just something like that. So there's actually, and the example that I'm using for this is called the MeBot, which is created by a guy's name I can't pronounce at the MIT Media Lab. And it's intended to convey the nonverbal channels of social communications, which means the just the hand gestures, the head movements, actual what you would be, how I'm conveying my message to you right now with my body. And basically what it is a robot that has, it's able to move, can move where the phone is in the picture, back and forth as I'm moving my head. And it will also follow your hand movements and replicate those to the person that you're talking to. So what it's intended to do against just a regular video conference is to keep both parties more engaged and more, I guess, interactive with each other. And you're just more alert, paying attention more to what the other person is saying. And just to give an example of what the robot does, I have a video of it here. So when you're talking to the person on the other end, you get a picture of them and the sound of what they're saying through the phone, plus how they're actually moving and responding on the other end by the robot.
Oh, that's creepy.
And of course right there, you know, is a long way in the distance, just having something that could look at you and you're not physically controlling it, and then replicate that on the other side with something a little better than a cell phone set into a small tiny robot. But the point is that the future of this would be to make your presence somewhere else much more resounding. It would make it seem like you're really there. Are there any questions?
All right.
Then I'll be able to do high five. Right.
You could do high five.
Energize.
So, hi everyone. I'm doing the robots applications for transmission lines, and the purpose for this was to reduce personnel who are working on transmission lines, reduce hazards for safety, and also to ensure the reliability of the transmission line. And it was the robotics for this industry was developed in 2006, and it was by a company called Hydro-Quebec TE Research Institute. And they had three types. There are three types of major robotics for this: ground-based, suspensions from the line, and aerial-based. Basically, in this presentation, I'll focus on suspension from the line, which has been the arms and the eyes of the man lines to do the maintenance on the transmission lines. There's the applications for this is to do visual inspections by cameras, and this is done where the camera does not touch the components. It only does it by zooming in and zooming out the cameras. And also sensing, it does corrosion on the conduction lines, where it measures the change in the diameter of the conductor. And also there's other applications for sensing, which is it measures electrical resistance in splices. A third application as well is possibly installing clamps on the robot, where the robot could do repairs on the transmission line. And for future, it's currently being remotely controlled. What they're trying to do is develop it as to be autonomous. Any questions?
Are the transmission lines energized while it's traveling them?
Yes.
That's how it gets its power. from the transmission line?
I think it has,
Batteries?
I can't believe it get its power because we're talking like
22
kilovolts, kilovolts.
yeah, I think it has.
If you suspend something, they
Just put out
don't
those
resist
those could be step down transformers. You know.
That'd be an awful big transformer.
Drop it down.
Well, see.
Drop it down to 12 volts.
All right. Next.
Good.
Hi, my name is Raju. I will be speaking on the Tucson Explorer 2, or also called as TEX. Now, this is designed for autonomous exploration on Titan. To give a short background on what Titan is, it's the largest moon on Saturn. It's the only known satellite known to have a dense atmosphere, only body other than Earth, wherein there is clear evidence of stable bodies of surface liquid. And the lakes that are found over there, they are hydrocarbon lakes. Right. The physical features of this particular robot, you can see, it can carry a payload of 150 pounds. So this is where you would keep the computer, the batteries, and the sensors. And it has two independently controlled propellers. They are air propellers that you can see up at the end of the robot. So this would allow it to travel forward, backward, and also spin, also turn sideways. There are a number of sensors that are being used here. These are used in order to measure the surface temperature, the wind direction, the wind speed, and intensity and duration of hydrocarbon precipitation. Three sensors at the top that you can see, the drop impact, the adaptive thermostat, and the ultrasonic. These have been modeled together to form this particular device. This is just a proof of concept. Then furthermore, you have cameras for it to travel, for it to navigate. The onboard GPS that is specifically being used for Earth-based applications, that is this is not yet ready to be deployed in Titan for the next 5-6 years. So till then, what can be done is it can be used to survey and to survey Earth water bodies. Right now, this is being controlled with a remote, but they'll be working on making it autonomous. So for navigation, we have various ways in which it can navigate. That is, it makes use of a blimp or a balloon overhead, which takes an image, converts it into grayscale and stuff like that. Finally, it's able to determine the actual location of the robot and then help it traverse through the terrain. Yeah, there's a YouTube link that we can have a look at.
Yes.
So as of now, it's just remote controlled, but they're working on making it autonomous. Any questions?
All right. Before we get off of this screen, I wanted to point something out, and that is on a lot of people's papers, you got something where I said improper reference of the paper. So I wanted to point something out because this is one that's actually correct. If you look at the actual reference on here, here's the title, very long title, the names of the authors, the specific conference. So actually this should have been in the proceedings of the 2012 IEEE Aerospace Conference, and then the page numbers. Often, sometimes you put the town. A web address is not a proper reference for a journal paper or a conference paper, or for that matter, anything that appears as a what do you call this, as a technical paper. All right, if you can get that, thank you very much.